All right, Unit 3, Lesson 11. Today we're going to talk about the addition rules for probability. So, what we're going to talk about here first is things that are mutually exclusive and not mutually exclusive. So, in order to be mutually exclusive, that means they are events that cannot occur at the same time. So, if you roll a die and the number comes up, whatever, that number can't be both odd or even. Theoretically, you can't be both a Democrat or a Republican. Things that would be non mutually exclusive, um, an odd number and a number that's less than 4, because you could have 3 or 1. An ace or a diamond, because you'd have the ace of the diamond. Being both a basketball player and a football player, or a football player, you can be both. So those things would not be mutually exclusive. Um, what you're going to have to do these things. So when I turn around and say, what's the probability of getting this or this? If they have any overlap, you're going to have to subtract that overlap away. We talked about that with the 9 of clubs or whatever that was from the previous lesson. So if things are mutually exclusive, you literally just add them together, their probabilities. And if they are not, then you add together their probabilities and take away the overlap. All right. So at a political rally, there are 20 Republicans, 13 Democrats, 6 independents, nobody that considers themselves more than one. If a person is selected at random, find the probability that he or she is either a Democrat or an independent. So, not that you can't do some of this in your head, but I'm going to write it all out here. So, we've got 20 and 13 is 33, and 6 is 39. So, the total is going to be 39. I want Democrats, which there are 13 of them, independents, which there are 6 of them, 19 out of 39. Follow the directions on whether it wants it as a fraction or as a percentage. Typically, we're going to do things as percentages. So 19 divided by 39, 48.7% approximately. All right, single card is drawn from a deck. Find the probability that it is a king, 4 out of 52, or a club, 13 clubs in a deck out of 52, and there is a king of clubs. So 16 out of 52. All right, last one. In the hospital unit, there are 8 nurses and 5 doctors. 6 of the nurses and 3 of the doctors are female. So I'm going to fill in the pieces that aren't here, which would be the males. So if you have 8 nurses and 6 of them are female, then that would make 2 male nurses. And then 5 doctors, 3 of them are female, that would make 2 male doctors. All right, so if a staff person is selected randomly, what is the probability that person is a nurse or a female? Okay, so there are 13 total nurses and doctors. 8 of them for nurses. For males, then, out of the 13, there are 4 of them. And then there are 2 male nurses. So we do those. So 8 and 4 is 12, minus 2 is 10. So the probability of picking either a nurse or a male would be 10 out of 13, which as a percentage is 76.9%. All right, that's lesson 11 from Unit 3. Let me know if you have questions.